Hello, in this video let's discuss fourth question of today's contest. You are given a non-integer number n. A non-negative is called binary palindromic if the binary representation is a palindrome. Return the number of integers k such that it is less than or equal to n and greater than or equal to 0 and it is a palindrome. And the binary representation is a palindrome. N is up to 115. So given an integer n, we have to return the number of binary palindromes which are less than or equal to n. So the numbers which should be a palindrome in binary. The first thing is the numbers are up to 10 power 15. So the highest bit is up to 50 because 2 power 50 crosses 1 is 15. So the highest bit also can be up to 50. So for a palindrome, if we set a bit at jth position, then automatically the bit will already be set in the mirror position of it also because it is a palindrome. So let's assume that we are initially at 0 bit and all are 0, like the whole number is 0 and we are trying to construct the number. So this is the whole number and all are 0 for now. We are at position 0. So if we are at index 0, if we try to set this 0, then what will happen? This will be the highest bit 50 bit will also become 0. And if it is 1, then it also will become 1. So for now what we can assume? We can assume that there is some function that is giving the list of palindromes between the set bits I and j. So here function of I and j represents the answer from 50 to 0. So if we find the answers for this, if we find the palindromes in this between indices, and then we can try to find this also. So for example, we have 49 to 1. Let's say we have got some list V that is palindrome in this bits. If we got this, then is there a way that can extend the answer from 50 to 0 using this middle one? Yes, because there are only two possibilities for 50 and 0. Both can be 0 or both can be 1. So given a middle vector V, we can duplicate V, which means that we are adding 0 bit at 0 and 50 bits. So given V from 49 to 1, the exact V can be used for a case where we are unsetting a bit, a present bit 0. And what is the other case? We can set the bit at 1 also, at 0th index also. So if we set, then these both will be set, and this is the new one. So if this is the number x, we are adding 1 at the 50th bit and we are adding it first 0th bit. So what will be the new value? It will be simply x plus 2 power 50 plus 2 power 0. So in this way we can try to find all the double values, one including the 0th bit and other offing the 0th bit. In this way we can try to find the answers. But as we are returning vector, it can be very long and we can get daily. So function of I and j, and if this is the case, then we can simply return function of 50 comma 0. So in function of 50 comma 0, we will find the function of 49 comma 1, and then we will try to duplicate this with other value where it is simply 2 power 50 plus that value plus 1. But this can give daily. But if we try to observe this, we are making very useless iterations for some cases. For example, the value is 10. If the number is 10, if it is 10, is there a case where 50th bit is 1 or 49th bit is 1? Obviously no, because it should be less than or equal to 10. So it should be less than or equal to 1001. So what is the use of thinking of all about higher bits? So from this we got that it is better to think with respect to the number of bits in the given number instead of blindly assuming from 50 to very less bits. So let's assume this is the number. If this is the number, thus the number of bits is 9. It is not the set bits, but it is simply the log of number. It means that it is simply the MSB. So if length is equal to 9, it means that 0, 1, 2, 3, 4, 5, 6, 7, 8. So MSB is 8. So if MSB is 8, the length is 9. So for length 9, is there a case where there is a set bit in higher position in this numbers, in these set bits, in these bits? No, because it should be less than or equal to this. So from this, if the length is 9, so we can find the answers for bit 8, because if the length is 8, it will be surely less than the 1 because the present one length is 9. So for a given length 9, we can add all the binary palindromes of length 8, all the binary palindromes of length 7, all till 1, right? Because if this is 9, the next one will always, if it is 8, it will already less than or equal to the present one. So for a given length L, so firstly, given an integer n, we can find the log of it or MSB of that, and given the length of the binary representation, then we can find the answer for all the list bits so that we can get most of the answer. right? So how can you find that? For example, let's assume that we want the all binary palindromes with length 6. How can you do that? For doing that, we can simply set the first half of that, so that other half will automatically be set because it is a palindrome. So for length 6, how many bits are in our hands? There are only 3 bits in our hands. So if we select all these 3 as per our wish, then these 3 will be automatically found. So what is the possibilities of numbers with length 6? It will be simply 2 power 6 by 2. So this is 6 and these 3 are in our hands. We can set these 3 or we can set these 3 also. Let's assume we are setting the highest set bits. So if we set these 3 bits, these will be automatically formed. And what are the number of possibilities? It is simply selecting these numbers, and which is simply 2 power 6 by 2. So there are 8 ways, 8 numbers of binary representation length 6 that are palindromes. And what if we try to find length 5, which is odd? So if it is odd, even now we have these 3. So even now, if it is odd, we can find the highest 5. We can find highest 5, but this is fixed. We can map these two. So even now, the answer will be 2 power 3. Maybe the new number is not exactly the number plus mirror, plus it is simply the whole number plus mirror of the first n minus 1. So in this way, even now the answer is 2 power 3, which is 2 power length plus 1 by 2. So even if it is 5, it is 2 power 5 plus 1 by 2. And even if it is 6, it is 2 power 6 by 2. So how can you do that? It is simply 2 power length plus 1 by 2. So if it is odd, then we will want the exact one. If it is even, then what we'll do? 2 power 7 by 2, which is simply 2 power 3, and which is exactly this. So 2 power L plus 1 by 2 will fit for both odd and length, odd and even. So for now, what we achieved. So given an integer n, we will find the length, and we found the answers for all the length less than or equal to L, less than or equal to L minus 1. And now the only thing left is what are the number of binary palindromes with length exactly L. That is the only thing we left, right? So now let's find how can we find that. Now length L is equal to L are left. So let's assume this is the number that is given. So what is the middle part? The middle part is what is the first half part? So this is the whole number. We are thinking about the first part, because setting the first half will automatically set the second half. And now what is the first half? It is simply triple one, double one, triple zero, because the length is 9 and the first 5 is the first half. So double one, triple zero, and these are unknown. So now what is the main goal? The main goal for now is to find what are the binary palindromes of length exactly L. So that this is the only condition left. And how can we find that? So, and now we also got the length now, because we are thinking about 5. So if we are thinking about 5, then what is the length? It is simply 5, right? So length is 5. And these are, no need to consider this, because if we say this, these will be automatically found. So for now, we have to think only about this 5. And how can we ensure that it is less than or equal to n? So that is the main thing, right? But for the before cases, no need to check if the numbers are less than or equal to n, because the numbers are itself with the less length than the present one. So it will be already satisfied. So now, what is the least right half that is possible? The least right half is simply the MSB is 1 and all other bits are 0. This is the least number, right, which can be found. So this is the least number. Hope you understand, because for now the main goal is only to set these 5 bits so that other 4 will be found. So how can we set these 5? Instead of thinking, let's think about the least condition. So what is the least number that is possible here? It is simply 1 and all other bits are 0. So if this is the condition, so this is the least number that we can think of. If this is the number that is fixed, then what is the new number that is formed with the length 9? It is simply 1 0 0 0 0 and mirror of these 4, 0 0 0 1. So this is the number that is formed. And what is the right half for the given number? Right half for the given number is 1 1 triple 0. And even now these 4 are don't care. And even these 4 are don't care, because these will be automatically setted. So this is the least number that we want, and this is the exact number that we have. So what are the numbers that are possible so that the number can be less than or equal to n? So for the given number, the given n bit is less than or equal to n because it is exactly n. So this will be satisfied. So now what is the main goal? The main goal is to select the first half such that even then the new number will be less than or equal to n. And when is that possible? When is that possible? It is possible that if the right half is less than this, right? It is obvious. So we have a given number and we want the new number also less than or equal to n. So when that is possible, if we try to construct the number less than this, less than the right half for now, it is obvious that the whole number will be less than or equal to n. So it is simply that the right half minus this one. That is the number of possibilities we have to select the highest MSB half bits. So 1101, let's assume this is the case we have, and 10001. This is the least number that we can have. And what are the possibilities that we have for these 4 bits? It is simply difference of these both, right? So 1000, 1001, 1010, 1011, 1100, which is simply the difference. And why is only the difference? Because if we set this, automatically other will be set, and this will make sure that the number is less than n, because we made sure that this number, this right half, is less than the right half given in the n. So it will be sure that the whole number, the final number, will be less than n. So these are the 5 possibilities we got. So, and let's ignore the case where it is exactly equal to right half, because there may be a possibility that it may overflow. For example, let's assume that we have 1101, 1000. So let's assume this is the number, and these are the 4 set bits. So from the above thing, what we got, we can use 1000 as the right half, 1001 also as the right half, left half, and 1010, 1100. So for now, let's assume these 4 only. 110. Okay, let's assume this is the one. And if these 4 are the possibilities we selected, then final number will be always all surely less than or equal to n, because the left half is less than or equal to n. So the left part is simply less than the left part of n. So we are sure that the final number will be less than or equal to n. So these are automatically found. And what are these numbers? It is simply the numbers that are between the left half of the given number and 1000, which is simply 2 power the right left bits minus 1. So this is the numbers between these both. So if you find the numbers between both, we will get this 4. So these 4, the answer will be plus 4, because we got 4 possibilities and we can simply mirror these both and we'll get less than or equal to n. So these are palindromes. So answer plus equal to 4. And now the only condition left is, what if the right half is left half is exactly the left half of n? So what is the only case left? The given number. We will select the left half first, half left half, and then if we try to consider exactly this left half, and then if we try to concatenate this with the mirror, and if this is also less than or equal to n, then we can get an answer. If this is greater than n, then we cannot find the answer. So we are considering all the conditions, right? So given a length n, we first found all the answers for less than or equal to n. So this made our answers more. And now the only thing left is answer for length exactly equal to length. So even for this, we found the possibilities for first left half, which is less than left half of n. So even in this case, all the numbers will surely be less than or equal to n, because we are considering itself the left part, right? So how there is a possibility that whole number will be greater than n? So even now it will be greater than or equal to n. And now the only possibility left is simply the left part is equal to left part of the given number. So if that is the case, then we can simply concatenate this with the binary part, mirror part, and then we can find if the whole is less than or equal to n. So if this is the possibility, then increase answer, else decrease, else no change. So this is very simple. We can find the answer. So hope you got how we are considering. So coming to the code, for example, we are considering left part. So how can we find 1000? So we can find the left part for the given number, right? We can simply make these highest bits, highest number of bits, where it will be simply middle Middle is simply length plus 1 by 2, which will cover both left and right, which will both cover odd and even. So we can get this, and we can get this also. How can we get it? Is simply 2 power middle bits, right? 2 power middle number of bits plus 1 by 2. So this is simply 1000. And coming to this one, we can simply traverse the bits from MSB to MSB minus middle, and then we can try to add in a string, and then we can convert to number. So got these two, then we can simply find the numbers between these, because we got the both integers. For example, these are 3 and 9. So given these 3 and 9, let's assume 9 for now, because we are handling the case where the left half is exactly equal to left half of the given one. So for now, let's assume we are removing that. So given 3 and 8, we want all the numbers between 3 and 8. So how is that? It is simply 8 minus 3 plus 1. So these are the 6. So 6 are the possibilities where the left MSB, the left half bits are surely less than the left half bits of the present one. So the final one will be simply less than or equal to n. So in this way you can find the answer. If you have any doubts, comment below. See you in the next video.